Hi, welcome to this particular module. In this module what we are looking at, the fundamentals of EEG, which is electroencephalogram, and how to design a electronic signal conditioning module for acquiring this EEG signal. Now acquiring, of course we can say that electrodes are used to acquire it, right, but to process the signal and to convert in a readable form we require an electronic module. So before we jump to EEG and the details regarding that and the signal conditioning circuit, let us also focus on a bit on ECG, EMG and EEG. They are kind of, like I said, related terms and sometimes it is confusing. So if you see the slide, these are the terms that you will come across: ECG, EMG, EOG, EEG, GSR. Okay. So ECG, electrocardiogram, it measures the heart activity. EMG, electromyogram, muscle movement. EOG, electrooculogram, eye movement. EEG, electroencephalogram, brain signals. GSR, galvanic skin response. We also have term called ECOG, electrocardiogram, and this also measures the brain signals or neuronal signals from the brain, while the EEG is on the scalp, ECOG is directly on the brain or signals from the brain. What is the use? The use is for breathing, if you know how the breathing is working, temperature, movement, etc. And what are the measured with other sensors transducers? Some sensors available are NTC, LDR, piezoelectric, Hall sensor, accelerometer, goniometer, and lot of sensors are available that we can use for this application. ECG, as we already know, right, it is generally, you have seen the ECG monitor whenever the patient is in the hospital, and it shows the performance of the heart or the quality of the signal that is generated from the heart, and generally we are understanding the PQRS signal, right, or in particular QRS signal and PQ signal, which shows the heart, the quality of the heart response. And also if you see, it is a heart, when you measure the signal, it is a vector signal. So the idea here is, if I want to measure the ECG, right, how we can measure this ECG signal, what kind of electrodes are there, how to connect this electrode. So the 12 lead ECG electrodes, how to connect it to the heart to measure the ECG is shown in the next video. I will just play the video.
Fast and accurate 12-lead ECGs with Tim Phelan.
Oh, hi. We're right now. Came in as a 45-year-old male complaining of some heartburn, maybe some chest pain. Wife says he started to feel a little sicker. Anything from indigestion to infarction, or a lot of things in between. But you know, this is and I'm doing it, so it's a pretty safe bet. This poor guy is going to be having an acute myocardial infarction. Why don't you come along with us and we'll show you how to do a 12-lead EKG. You ready? Let's go.
Tim Phelan is a seasoned paramedic with more than 18 years in EMS. An internationally known author and educator, he has trained more than 25,000 paramedics and nurses on diagnostic 12-lead ECGs.
Thanks for the nice intro. You know, the American Heart Association, in Chapter 9 of their new textbook, talks about the acute coronary syndromes, including myocardial infarction. And it makes some pretty bold statements. It says that emergency care providers, that you and I, need to be familiar with the core principles of diagnosis and treatment of these acute coronary syndromes. It also says that the 12-lead ECG stands at the center of decision making for these acute coronary syndromes. Okay.
12-lead ECG is a routine part of the assessment of a patient with possible ACS. Included with the history, symptoms, and vital signs, the 12-lead ECG is critical to the diagnosis and treatment of the cardiac patient.
A little chest pain, is that right? No. Tell me again what you were doing when the pain started.
Explain the procedure and reassure the patient. Remove the clothing on the upper body. Wipe the electrode sites with a brisk dry rub. Oily, dirty, or diaphoretic skin should be quickly cleaned with an alcohol wipe.
This is a really routine standard stuff.
Allow the skin to dry before placing the electrodes. If necessary, shave or clip hair on electrode sites.
There you go.
The ECG is best obtained with the patient resting in a supine position, lying as still as possible for the 10 to 15 seconds required for the ECG device to acquire all of the information. The patient must be relaxed, warm, and as comfortable as possible, with all limbs supported. If the patient is uncomfortable or having difficulty lying flat, place him in a low-sitting position and make a note on the ECG printout.
Well, you get the basic idea. But I would like to take a minute to go over a couple of key points. First, scene time. Studies and experience have shown that getting a 12-lead ECG does not prolong scene time, so don't be concerned about that. Second thing, getting a 12-lead really is pretty easy. Once you've done a few of these, you'll see for yourself. The truth is, the skills you've learned already are far more difficult than 12-lead acquisition. And remember, getting a 12-lead makes a difference on scene, en route, and arrival at the hospital. Of course, to be valid, it absolutely has to be done correctly. So, let's talk about ECG monitoring in general. Everyone is familiar with leads 1, 2, and 3. You learned about them in school, you've been using them for years on your job. And when you've used them, you did it for the purpose of identifying cardiac rate and rhythm. Now, each one of those leads is a view of the heart. Each one of those 3 leads has a single positive, a single negative electrode, and a ground. The actual view of the heart is seen from the positive electrode toward the negative electrode. That's why each of the complexes have a slightly different configuration. The ground electrode helps to reduce electrical interference and helps produce a clear tracing. To get a 12-lead ECG, we must isolate only the heart's electrical signal.
The human body and external environment have many sources of electrical signals. The electrocardiograph can detect and reproduce the various electrical signals of cardiac conduction. The monitoring frequency response mode provides a 0.5 to 40 Hz view of cardiac conduction, while the diagnostic frequency response mode provides a 0.05 to 150 Hz window. This broader frequency bandwidth accurately reproduces cardiac electrical data necessary for diagnostic interpretation of the status of the myocardial muscle, which may be reflected in the ST segment of the cardiac ECG complex. The ST segment is found in the lower end of this electrical frequency window. An accelerated rate of play is assumed as the eligible receiver runs a complicated pattern downfield. The two racks protect the center in a lane and lane at angles easy. The elevation of the plane surface.
Whoa! Time out. That's the textbook version of frequency response. Here's the real-world version. You see, the difference between 3-lead monitoring and 12-lead monitoring is not the number of wires coming out of the machine. The difference is frequency response. In monitor quality, the machine is not attempting to reproduce the full spectrum of cardiac electrical activity. Instead, it's just focusing in on the center portion so it can see the QRS complex so you can do rate and rhythm. In the process, it's filtering out some artifact, which makes the ECG clearer. That's terrific. But you cannot do this for ST segment analysis because in monitor quality, you can't see the ST segment properly. That's why the 12-lead has to be done in diagnostic quality. In diagnostic quality, the machine is able to see the full spectrum of cardiac electrical activity. Not only the QRS complex, but the ST segment as well. You notice that the artifact is seen a little more clearly as well, but because we need to see the ST segment, all 12 leads must be done in diagnostic quality.
The 12 views of the heart are taken with 10 electrodes. The 4 limb lead electrodes do not require precise anatomical placement. However, it is best to avoid sites that have a lot of hair, large muscles, or bony prominences. The upper limb electrodes can be attached anywhere along the arms, from the wrist to shoulders, as long as they are off of the torso. The lower limb electrodes may be attached anywhere from the ankles to the thighs. The 4 limb electrodes provide a total of 6 leads, leads 1, 2, 3, AVR, AVL, and AVF. All limb leads provide a view on the vertical or frontal plane of the body. The 12-lead ECG adds 6 views through electrodes placed on specific points on the chest wall. These chest leads, also called precordial or V-leads, provide a view on the horizontal plane of the heart.
The international standard for 12-lead placement requires that the limb leads be positioned on the limbs and not the torso. In reality, however, some emergency departments obtain the limb leads from the patient's torso. In that case, you may opt to do the same for the sake of consistency. So, while there may be some variation in limb lead placement, there can be no variation in chest lead placement. The chest lead electrodes must be obtained from their specific anatomic landmarks. Let me show you. Find the clavicle and position your finger just below it. Move your finger until it contacts the sternal border. You're in the first intercostal. Find the second, third, and fourth intercostal space. Position the electrode for V1 just to the right of the sternum in the fourth intercostal space. V2 goes in the corresponding intercostal to the left of the sternum. Skip V3 for the moment. V4 goes in the mid-clavicular line, fifth intercostal space. V3 is positioned between V2 and V4. The V5 electrode is horizontally level with V4 in the anterior axillary line. V6 also horizontally level with V4 in the mid-axillary line. Notice we did the 12-lead ECG on the scene. This was very intentional. For a variety of reasons, the ECG may change quickly, and the early tracing may provide very valuable information. Let's take a look at some tracings. The first shows gross and obvious changes. The second tracing was obtained from the same patient only a few minutes later, and the changes have all but disappeared. That's why it's important to get the first ECG with the initial set of vital signs. Get a repeat ECG every 5 to 10 minutes, or at least with each change in patient condition.
Okay. So, you have seen in the video that how these electrodes are connected to measure the ECG signal. Now, let us see what are the applications of this ECG. If you see, the ECG applications are many, right from the diagnostics, that is the heart performance, function analysis, if there is an implant, then implant is working properly or not. We want to know the heart variability, which is HRV, and we also want to know peak performance training and monitoring. That means that if a person is let us say performing an exercise, right, at what rate the heart shoots up, what was the maximum heart activity, how it is shooting back down, or how it is coming back to its normal beating mode or rhythmic mode. Everything we can measure if we know the ECG signals, right. There are a lot of companies working on the variables to understand the ECG. Now, let us go to the second. See, we will not spend much time on ECG and EMG, we will spend more time on the EEG signals. So, EMG, when you talk, EMG is the signals obtained from the muscles, and generally the EMG signals are around 3 millivolts, which is a huge signal, similar to your heart signals, which are a few millivolts. The electrodes are placed, and if it is a wet electrode, again you have to use a glue to attach these electrodes. There is a gel also which is required to be attached, to be used with electrodes to reduce the impedance. And you can see here that you will see when the muscle contract, the signals would change. When you relax the muscle, the signals would change back. So, EMG electrodes are passive in nature, and there are other electrodes which are active in nature. So, two types, passive and active. This Myoscan is a company which makes the active electrodes. Now, if I want to see how the EMG signals are generated, let us see this video and then we will take it forward.
NCV EMG derivations comprise a multitude of investigatory measurements as well as their electrodes and accessories. GVB Gilimit will supply you with the electrodes required for stimulation and derivation, including the appropriate accessories ranging from cable connectors through pastes and creams. These will be of optimum quality, permitting you to carry out derivations with no complications and to receive stable results. Now you see a standard NCV EMG investigation using different stimulation and derivation measurements, as well as a special form of neurography, the blink reflex. Prior to the neurographic investigation, a ground electrode is placed over the wrist between the recording electrode that has yet to be positioned and the stimulation area. Finally, this is connected to the EMG instrument by a snap cable. In motor neurometry, neurography, the recording and stimulation areas should be decreased before the recording electrodes are attached. Following this and using the belly tendon technique, the active electrode should be positioned on the muscle belly and the reference electrode above the attachment of the tendon. In this case, tab adhesive electrodes with crocodile clip lead wires are used and connected to the EMG instrument using a multifunctional cable. Various types of multifunctional system electrodes can be connected to this multifunctional cable. However, snap cables that fit the multifunctional system and snap adhesive electrodes can be used as an alternative to the crocodile clip cables and tab electrodes. Waffle electrodes are a further alternative. However, electrode gel should be applied prior to use to guarantee a good electrode resistance. The electrode itself is attached using adhesive tape. Plate electrodes that are employed in the same way, and disc electrodes that also have electrode gel applied to them and are fixed using adhesive tape, form part of the multifunctional system electrode program and can be used as alternatives. The stimulation electrode should be ready prepared for use. For this, sweep the stimulation balls into the electrode appliance. If you are using stimulation electrodes with felts, soak these in NaCl liquid prior to inserting them into the appliance in order to guarantee good skin contact and a good resistance too. However, the felt must be dried well to avoid wetting the skin. The next step is the connection of the stimulation electrode to the EMG instrument. The stimulation electrode is placed over the nerve and the stimulus is increased following a predetermined sequence until maximum amplitude is reached. The user observes motor reaction as a control. The stimulus is increased until a supra-maximum stimulation is attained, recognizable by the fact that there is no further increase in amplitude. The cursor is set exactly to the initial negative potential output. The highest and lowest points in the curve determine the amplitude's magnitude. The electrodes must also be moistened with NaCl when stimulating with finger-toe stimulation electrodes. However, the electrodes should not be wet. Therefore, dry the electrodes with a cloth. A ground electrode is also placed over the wrist between the stimulation electrode and the stimulation area prior to connection the EMG instrument when using stimulation in sensitive neurography with finger-toe stimulation electrodes. First, the cathode is attached proximally to the finger base joint and the anode is then attached distally to the fingertip. There should be no liquid bridge between the two loops, which can, however, be ensured by prior drying to the electrodes. Finger-toe stimulation electrodes are also a part of the multifunctional system and can now be connected to the EMG instrument by the multifunctional cable. The sensitive recording electrode is positioned directly over the nerve above the wrist, attached using Velcro tape, and then connected to the EMG instrument. This stimulation and recording electrode has already been used as a stimulation electrode in the previous section. The orthodox method shows the first variations of sensitive neurography. During stimulation with this method, stimulation is carried out supramaximally, an example until the amplitude increases no further. This is similar to the approach taken in motor stimulation. Then the signal is averaged online. A sensitive nerve action, potential-free of noise, is obtained after averaging approximately 20 to 50 times. The antidrum method shows the second variation of sensitive neurography. In this case, digital ring electrodes are used as recording electrodes. The active electrode is attached proximally and the reference electrode attached distally in this method. These electrodes, that are also parts of the multifunctional system, can be connected to the EMG instrument by the multifunctional cable. Contact gel must be applied to the contact surfaces on the metal loops once the ring electrodes have been connected to the EMG instrument. This guarantees an optimum contact resistance. In antidrum sensitive neurography, recording occurs from the skin and the respective peripheral nerve is stimulated. Antidrum stimulation is advantageous as it is a rapid method with a high response amplitude. However, motor overlaps can have an effect on this method. Our Myoline needle program supplies EMG needle electrodes of different lengths and diameters for the pain-free investigation of superficial muscles, deep muscles and also small hand and fascialis supplied muscles. These needles can also be connected to the EMG instrument using the multifunctional cable. Specialized forms of neurography like the F-wave, or as shown in our example, the blink reflex, can be applied extremely well using disposable adhesive electrodes or disposable adhesive snap electrodes. The respective reference electrode are attached above the nasal wings and the active electrodes are attached above the respective orbicularis oculi. These electrodes can then be connected to the EMG instrument using the multifunctional cable. To prevent an ACL liquid from being released from the felts and running into the eye. For the stimulation, it was used a stimulation electrode with stimulation balls. The blink reflex can thereby be derived free of add effects. Several curves must be overlaid and the R1 and R2 components on the stimulatory side and the R2 component on the contralateral side are determined. Alternatively, disposable adhesive electrodes can be used. In this case, a ground electrode is first placed on point N and then connected to the EMG instrument. The adhesive electrodes are then attached to the respective orbicularis oculi as done previously with the reference electrodes and subsequently connected to the EMG instrument with 1.5 mm safety connectors. To prevent liquid spills, a stimulation electrode with stimulation balls is also used in this blink reflex recording.
Okay, so you understood how this in the video how the EMG electrodes can be placed and how the signals are generated. Now let us see, similar to ECG, what are the application? Let us see EMG and its application. EMG can be used for several applications including rehabilitation, functional analysis, active prosthesis, orthosis, biomechanics, sports medicine. Also recently the face muscles gives lot of information about the vitals of the body. So it can be, we can also use myoscan EEG sensor which is shown here, then we can use goniometer, we can use force transducer to help the person to balance, which is generally used in the rehabilitation application. Also for prosthetics also, if it is a prosthetic then person has to get acquainted with the prosthetics, and that is why EMG signal feedback is extremely important, right. So till then you take care, I will see you next class.